Hello students, welcome back to your one and only favorite YouTube channel, Tomachang Tutorial. Myself, Kishan Kulun, and today we are ready to discuss about factor theorem in the chapter called polynomials. Okay, let's begin. If fx is any polynomial with degree n, where the value of n is greater than or equal to 1 and a is any real number, then we are asked to prove these two conditions. Number one is x minus a will be the factor of fx if fa equals to 0, and number two is if fa equals to 0, so fa equals to 0 if x minus a is a factor of fx. Okay, these two are the conditions which we are asked to prove. Okay, let's first understand the polynomial is fx and this polynomial is divided by x minus a. I am trying to prove number one. Okay, if the polynomial fx is divided by x minus a, isn't it? Then from the remainder theorem we know that from the remainder theorem we know that if the polynomial fx is divided by x minus a, then dividend equals to quotient into divisor plus remainder, isn't it? So dividend is fx equals to quotient is divisor is x minus a and quotient is qx. I am just supposing this quotient to be qx. Okay, x minus a into qx plus remainder, isn't it? Where remainder is fa, remainder will be fa, isn't it? From the remainder theorem we know that if fx is divided by x minus a, then the remainder will be fa, isn't it? So remainder is fa, where qx is quotient. Let me write here, where qx is quotient. This is the general equation which we have already seen in the remainder theorem. If fx is divided by x minus a, then the relation will be dividend equals to divisor into quotient plus remainder. Remainder will be fa. From the condition we know that fa is 0, or fx equals to x minus a into qx plus fa is 0, isn't it? Fa is 0. Therefore fx equals to x minus a into qx plus 0, no need to write, isn't it? Now from this we can understand when we multiply x minus a and qx, the product of x minus a and qx gives fx, isn't it? Therefore we can say x minus a is the factor of fx. Suppose 3 and 2 multiplies gives 6. 3 and 2, when we multiply 3 and 2, the product is 6. We can say 3 is the factor of 6, or 2 is also the factor of 6. 3 and 2 both are the factor of 6, isn't it? Similarly, when we multiply this term and this term, this into this gives the product fx, means x minus a is the factor of fx. Therefore x minus a is a factor of fx, of the polynomial fx. Okay, number one is proved, this one. Now let us prove the second one. Please take the screenshot. Now let's prove number two. Okay, this fa equals to 0 if x minus a is a factor of fx. Since x minus a is a factor of fx, isn't it? Of the polynomial fx. X minus a is a factor of polynomial fx. From the same relation, fx equals to divisor into quotient plus remainder, isn't it? So the remainder should be 0. When the remainder becomes 0, then only x minus a will become the factor of this, isn't it? We have seen in the earlier case this one. X minus a into qx gives this, means there should not be remainder. The remainder should be equals to 0. Okay. F a should be equals to 0. Then only x minus a when multiplied with qx gives the product fx. So this is the relation. From here, if let us say let x equals to a, if x equals to a, then fa will be x, isn't it? X means a minus a into q, x means a. Qx is the quotient, okay? Or fa equals to a minus a is 0. A minus a is 0. So 0 into qa gives 0. Therefore, fa equals to 0. Fa equals to 0. This is proved, okay? I hope you understood the factor theorem. So we will move on to the next topic, that is exercise 7.4. We will solve each and every question of exercise 7.4. But before that, if you are new to this channel, please subscribe the channel and click on the bell icon to get notification for more video uploads. Thank you.